to talk about two different types of series, a convergent series and a divergent series. If the sum of an infinite series adds up to a finite number, it is convergent. So we're going to skip B for a moment and go down to number 1. So a reminder, a series is the sum of the values of a sequence. I'm just going to say of a sequence. So you add up all the numbers in a sequence, that's what a series is. If the values along the sequence approach 0, then an infinite series can be determined. So this is something that we've talked about already, that when the values of a sequence are approaching 0, you can find the sum of an infinite number of terms of that sequence. So then number 3, if a series can be determined, I'm going to say if it can be determined, then it is called convergent. It's called convergent because it actually converges on a finite sum. So if you find that a sequence, an infinite sequence, has its values approaching 0, then the infinite series can actually be determined. It is a finite number, and it is converging on that finite number and getting infinitely close to it. So it is called a convergent series. If number 2 is not true, if the values do not approach 0, then it does not converge on a particular finite sum, then it is called divergent. So here's a series: 1/2, negative 1/4, 1/8, negative 1/6, 1/32, negative 1/64. What's happening is we're multiplying by negative 1/2. These 3 dots here mean therefore. Therefore, the absolute value of r is less than 1, which means the infinite series can be determined, so it is convergent. So we can see that these terms, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, I forgot to say negatives on these 3, but they are getting closer and closer and closer to 0, which means that this series will converge on a particular finite sum, so it is called convergent. So all we want to do with these next 4 examples is tell whether the series is convergent or divergent. So in this case right here, we've got 2/3, 1/3, 1/6. I think we're looking at a geometric series here. So if that's true, then 1/3 divided by 2/3 will be the same as 1/6 divided by 1/3. So we've got 3/6, which is 1/2, and we've got 3/6, which is 1/2. So r is 1/2, which means the absolute value of r is less than 0. I'm sorry, is less than 1. The absolute value of r is less than 1. And since the absolute value of r is less than 1, it is geometric. So it says tell whether it's arithmetic or geometric. So it is geometric. And because its absolute value of r is less than 1, it is convergent. which means we could find a finite sum of that infinite series. This next one looks like it might be arithmetic, so I'm going to try -2 minus -4, and 0 minus -2. So -2 minus -4 is -2 plus 4, that's 2. 0 minus negative means plus 2, and that's also 2. There is a common difference of 2. So it is arithmetic. And anytime a series is arithmetic, that means it's going toward infinity or negative infinity. There is no limit to the sum. It does not converge on a particular finite sum, so it is divergent. Looks like here we're multiplying by 3. 3 over 1 is 3. 9 over 3 is 3. So there is a common ratio of 3. So it is geometric. But the absolute value of r is not less than 1. So it's not going to converge on a finite sum. So it is divergent. And last, looks like we're probably geometric here. So -2/5. Change color so this doesn't all run together. -2/5 over 6/5. These 5s are going to cancel, so we've got -2 over 6, which is -1/3, and 2/15 over -2/5. So I've got -10 over 30, which is -1/3. Okay, so I've got an r of -1/3. The absolute value of r is less than 1, so it is geometric, and it is convergent.